Dear students, this question from JEE 2019 was asked from the chapter Electric Charges and Electric Fields. Question is, charge is distributed within a sphere of radius r with a volume charge density rho r equal to a upon r square e raised to minus 2r by a, where a and small a are constant. If Q is the total charge of this charge distribution, then the radius R is what? And these are the options. Now see here, the volume charge density that is given to you here, rho R, that is capital A upon R square e raised to minus 2R upon A. इसका मतलब ये हुआ कि सेंटर से सरफेस तक जैसे आप जाते हो, then charge density is continuously changing one. And we have to find the total charge distribution. तो इसमें हम क्या करेंगे कि सपोज ये हमारा स्फीयर है जिसकी रेडियस कैपिटल आर है. तो कंसीडर वन स्मॉल thin spherical shell having radius equal to small r, like this, and its thickness that is very less, very small, and that is equal to dr. So here what we have to do, we have to consider this sphere is made by this type of so many concentric rings, spherical cells, and for each one we have to find the charge on that particular spherical cell, and then after we have to take the summation. So in this type of cases, what we do, first we think about the charge on this particular spherical shell of radius small r, and then after we take integration of that from small r equal to 0 means the center to small r equal to capital R up to surface. So with this concept we can solve this one. अब देखो कि charge residing on this particular thin spherical shell, that is charge density. Charge density means charge per unit volume into volume of this particular spherical shell. And then integration of it will give you the total charge residing on the entire sphere or distributed over the entire sphere. Now, substitute the value of rho. So that is a upon r square e raised to minus 2r by a. Integration that we have to carry out between limits 0 to r. And volume of this thin spherical shell. So area of the shell, that is 4 pi r square, into its thickness, that is dr. Now, here r square cancelled. 4 pi a, the constant is taken out of the integration. So we can write integration 0 to r e raised to minus 2r by a dr. Now, 4 pi a, integration of this one, that is e raised to minus 2r by a upon minus 2 by a, and limits are 0 to capital R. Now, if we substitute the limits here, then we will get 4 pi a into this minus 2 by a, which one is in denominator, that we can write in numerator as minus a by 2, e raised to minus 2r by a. So here small r is replaced by capital R, and when you substitute small r, that is equal to 0, then e raised to 0, that is 1. So here we can write e raised to minus 2r by a minus 1. Now q, that is equal to 2 pi a into 1 minus e raised to minus 2r by a. Now Here, the total charge distribution Q, which one is given to you, that is calculated. But from this one, we have to now calculate the radius, okay? Because our final answer asked, that is for radius. So Q upon 2 pi AA, this one is taken on left hand side, equal to 1 minus e raised to minus 2r by A. Therefore, e raised to minus 2r by A, that is 1 minus Q upon 2 pi AA. And now if we take log on the both side and then we make r as a subject of equation, then we'll get r equal to a by 2 log 1 upon 1 minus q upon 2 pi AA. So our answer, that will be 4. Clear? Any doubt?